In this video, we're going to talk about not only the differentiators of Scalr versus Terraform Cloud, but also the similarities. When you're evaluating other products from Terraform Cloud, whether it's for pricing reasons, whether it's for license changes, whatever it might be that's been happening recently, it's important to understand what new functionality you're getting, but also how your day-to-day life for your users and your engineers will not drastically change. Scalr was created as a drop-in replacement for Terraform Cloud, and that's what we're going to talk about in each one of the segments in this video. The way this video was created was to allow you to choose the sections you want to watch when you want to watch them. So you're going to see the flow of this a little bit different, where we're going to jump from feature to feature, but in the settings below in YouTube, you'll be able to select the section that you care about most and jump from section to section to focus on the areas that you want to learn more about. So first off, let's talk about the organizational model in Scalr. In Scalr, we have what we call an account scope, environment scope, and then workspace scope. All of this is built with inheritance in mind. The first differentiator you're going to see is that at this account scope, you're going to manage essentially all objects for the rest of the platform. So that's where you're going to create your users, your teams, providers, provider configurations, modules, variables, your OPA policies, integrations with things such as Okta, Slack, Teams, Datadog, and more, where you create your VCS agents or your run agents. And then lastly, you also have reporting and dashboards across all of your environments and workspaces in a single place. Now, once we go down a level, we then see Scalr environments. Scalr environments are the equivalent of either Terraform organizations or Terraform projects, depending on when you started using Terraform Cloud. If you use Terraform organizations to separate your workspaces in Terraform Cloud, that's the same concept as a Scalr environment. Now, some companies use one Terraform organization and then multiple projects within the organization. In that case, think of a Scalr environment as the equivalent of a Terraform project. The real goal for Scalr environments is to logically separate out your workspaces, your teams, users, policies, modules, and more, so that your engineers, your developers have an isolated area to do their deployments. Underneath environments, we then have workspaces. These workspaces are the exact same thing as you're accustomed to in Terraform Cloud, in the sense that that is where all the settings for the Terraform deployments are set. So it's also where you're going to have your run history, all of your state files, the variables associated with the workspace. So really the concept of a workspace in Scalr is the equivalent of what you see in Terraform Cloud. So from an organizational standpoint, again, environments are going to be similar to your Terraform Cloud organizations or projects. Workspace is the same thing. But the main differentiator here is now you have this admin or account scope that does not exist in Terraform Cloud, where you can store your objects. Those objects are then shared or assigned down to the environments and then inherited by the workspaces. You then have the reporting functionality and the dashboards at the account scope. That only exists in individual Terraform Cloud organizations, not in their overarching account scope, which they do not have. So what does this actually look like in Scalr? So right now I'm logged into the account scope, where all the platform admins are going to operate. Within there, as I mentioned before, this is where you're going to create your teams, your users. You're going to view reports, create provider configurations to link to your Terraform providers, such as AWS, Azure, Google, and whatnot. Manage policies, integrations, see all the workspaces it runs across all of the environments. But what you're mainly going to do when you first start out is then create your environments. So when you're creating environments, as we see here, you're going to want to set VCS providers. So VCS providers are how you are able to pull in the code into your workspaces, how you enable modules in the module registry, how you enable OPA policies, as those are also pulled in. You're going to link provider configurations, which are done at the environment scope in Scalr, which is a differentiator. So anything that is assigned to this environment, which we have app Athena, any workspace created in there is automatically going to inherit these provider configurations and inject it into a run. You don't have to do it at the workspace level. You'll also see that we have the OPA policies assigned to the environments. Again, these live at the account scope, but we're actually assigning them in the environment itself. We have our access policies, so which users and teams should be able to access this app Athena environment and deploy the workspaces and Terraform code directly in there. And then, of course, we have variables, whether it's Terraform or shell variables, and anything created at the account scope is automatically inherited here, as we can see. And then we can also create variables in this environment context, which is then shared down to the workspaces below. So really think of this overarching account scope or admin scope as where you're going to operate the entire platform, where you have that overall umbrella to see what's going on, to manage those guardrails and policies and various integrations. And then below there, you have the environments where the teams are going to actually deploy their workspaces. So if we go in here and we just click on jump to environment here, as you can see now, we have some workspaces in this app Athena environment, and these workspaces are where the actual runs are executed and where your engineers and your users are going to do the majority of their work. All right, so we're in the Scalr UI here, and we're actually in a workspace itself. And the first thing you're going to do when you're creating workspace is select the workspace type. So it's going to be CLI based, where you'll use the native Terraform or Tofu CLI to execute runs. Is it going to be VCS based, where you integrate with something like GitHub to enable GitOps automation? Or is it going to be module based, where you're actually deploying a workspace linked to a module from the Scalr module registry directly in the Scalr API UI or CLI? In this case, we have it linked to the CLI workspace type. And what you'll see here is I have some local code where I've added Scalr as the remote backend, and we're using the Scalr provider to then create the environments and workspaces. What you'll see here is that you're going to get the standard output you normally expect. If I flip over to the Scalr UI, you'll also see that here as well. So standard remote operations backend, I should say, where you're executing with the native CLI. Now switching over to the VCS workspace type. As you can see, I've already enabled my GitHub application, linked it to a repository branch. If I had a monorepo, I can set working directories. I can set patterns to focus on specific files or exclude files, enable dry runs, clone submodules, and whatnot. So what I'll do here is I'll just come into my local code. As you can see, I don't need the remote backend in this case because it's linked to GitHub, which we have a webhook with. And we're just going to update this to a /16. And we'll push that into Git. Once we push it up into Git, we'll see that it has come into staging. We can open up a PR on that and create pull request. And what Scalr is going to do, just like you're accustomed to in other solutions, it's going to automatically create dry runs or speculative runs. What Scalr is doing right now, if I flip back into here, is we're executing a run. It's going to go through the plan, cost estimate, and policy check, but we're going to skip the apply. All the results are going to be sent back into GitHub, where we'll see either it's successful or not, and update the checks accordingly. All right, so now we see the results back into Scalr, where it's going to tell you overall summary. If I had this linked to multiple workspaces, we have our cumulative summary where it aggregates all the workspaces, and then we have our per workspace report. Now switching over to module-based workspaces, I'm going to switch to a different environment we have here. In a module-based workspaces, those are deployed directly from the module registry. In Scalr, you can see that modules are either labeled with the account label or do not have the account label. Anything labeled with the account means it's coming down from the account scope. So Scalr does have a cross-account module registry that's shared across environments, or you can create those modules in specific environments. In this case, I'm going to create an S3 bucket, and I just want to create it directly from the UI and create a workspace out of that. We're going to update this to S3 demo. Automatically defaults to the module version. We'll go ahead and create that workspace. And now it's going to pull in the configuration and let us know that we have some values that are required, but not yet set. So this is just asking for a bucket name. We'll go ahead and fill that in, create and finish. We've satisfied the requirements, and now we can queue a run. Once queued, back into the same pipeline. So as you can see, if you're accustomed to those 3 different workflows in Terraform Cloud, you're getting the same experience in Scalr, whether it's using the Terraform CLI, the VCS or GitOps workflow, or lastly, the no-code provisioning through the module registry. All right, so switching gears here, we're going to talk a little bit more about reporting in Scalr. So in Terraform Cloud, there is the concept of an Explorer. That Explorer gives you some reporting functionality in a Terraform Cloud organization, and is specific to that Terraform Cloud organization. Now, if you have multiple organizations, you cannot see any reporting there is not an Explorer across all of those. And the key differentiator in Scalr is that our reporting is at the highest level, And the reports show everything across all environments and workspaces in a single place at our account scope. So for example, if I wanted to see which Terraform versions are in use and maybe filter out and find anything that is below 1.0, I can build that filter. And now I see all of my workspaces across all of my environments. I can easily identify those workspaces that need to be updated and contact their owners. The same concept for providers and modules. Example here is for modules, we see all the modules that are in use, the namespace, where they're actually getting pulled from. And we're also seeing how many modules are used, how many modules that are out of date. So they're using an older version rather than the latest. And in here, we can click into any of these and find out more information about the workspaces and where those workspaces reside. That same concept exists for Terraform resources, for example. So if I want to see where AWS instances are deployed, I have all that information directly in here. And again, this is across the entire Scalr account, all of the environments and workspaces. We have that same concept, but more of an operational perspective when you look at the workspace dashboards. The workspace dashboards are showing you all of your workspaces across all of your environments in a single place, and you have the ability to then take bulk action on those if you want to. Same concept exists for runs. So those runs that are currently in queue, maybe waiting for approval or pending, you can see that all in a single place, again, across the entire account, as well as that run history. So the main differentiator here is that all of this information is aggregated across all environments and workspaces into a single place at the account scope for admins to easily find out the information they need to, where in Terraform Cloud, this only exists per Terraform Cloud organization, and you'll have to jump from organization to organization to use that reporting functionality. Okay, now on to the module registry. In Terraform Cloud, you can create a module registry per Terraform Cloud organization. Each one of those organizations will have a different module registry with no overarching registry that could be shared across them. In Scalr, you can create the module registry at the account scope or within environments, or have a cumulative approach where you have some modules coming from the account scope, some coming from the environment scope. So right now I'm at the account scope where we have a number of modules that have been created, and these modules are maintained and managed by the administrative team. All of these are synced with our VCS provider, and we can update them, delete them, change them, do whatever we want here at this account scope as I have administrative privileges. Now, if we go into one of the environments, we will see in the module registry, there's different labels on these. So anything that is labeled with this account label means that it's coming down from the account scope module registry, and it is shared across all environments, not only just this CS-M environment that I have, but all of these other environments in there. Now, anything that we see without the account label, for example, the security group, instance, or IAM module, this has been created in the CS-M environment. Only the users in this environment can actually see it. So if we're going to compare this again to Terraform Cloud, really Terraform Cloud just has the ability to create modules within specific, it would be the equivalent of Scalr environments, rather than having the ability to do it at the account scope plus within the environment. So really the differentiator here is Scalr gives you that flexibility if you want to have that, if you have modules that, everybody, all your users are going to use, you create at the account scope. If you have modules that only specific teams will use in their environment, you create that in the environment scope if they have the proper permissions to do so. Okay, so let's talk about agents now. So in Scalr, there are two types of agents. When you're creating an agent, you first off want to select, is it going to be a VCS-based agent or is it going to be a run agent? Run agents are going to be the equivalent of what you're used to in Terraform Cloud with self-hosted agents, same concept. Now, the big differentiator with Scalr's run agents is that every time you deploy an extra agent, you get an extra 5 concurrent runs. You're in control of your run concurrency when you're using agents. With VCS agents, which don't exist in Terraform Cloud, you have the ability to connect to a VCS provider that is within a network that might be behind a firewall. With run agents, you can select workspaces, and in those workspaces, you simply go in check Use Agent Pool and select the agent pool that you want to use for that workspace, and the runs will then execute on there. So in terms of similarities, yes, we both have self-hosted agents, but that's really where it ends. Main differentiator with Scalr is extra run concurrency for each agent that is deployed, and then having the ability to use VCS agents. Okay, so now we're going to talk about provider configurations. Provider configurations are the way that you authenticate to the Terraform providers in your Terraform configuration files. In Scalr, we have a couple built-in provider configurations with the major public clouds like AWS, Azure, Google. You also have the option of adding custom provider for any other provider there is, for example, GitHub, Datadog, whoever else might be out there, where you add in the parameters you normally would add in that provider block. Now, the similarities between Scalr and Terraform Cloud is that we both support the ability to authenticate to these major providers using things like OIDC authentication for AWS or assume role or access keys. But the key differentiator for Scalr is that the provider configurations are actually managed at the account scope in Scalr by somebody with the proper permissions, most likely an admin. In Terraform Cloud, much of this configuration is actually done within a workspace, so it's a workspace by workspace setting. Now in Scalr, when you create a provider configuration, you're going to set it to either use all current and future environments, or you're going to pick and choose the environments that it should be set for. When it is applied to an environment, it is then available to all workspaces within that environment. You also can set within the environments themselves defaults. So in this case, we have an AWS provider configuration named docs, and that is set as the default any workspace that is created within this app Athena environment. They also have the option of assigning other AWS credentials, where you can add aliases or OCI credentials, GitHub credentials, or even the Scalr provider configuration. If I go into the app Athena environment here, what we'll see is that if I was to create a new workspace, it is automatically going to show and assign the AWS provider configuration for me, specifically the docs, because that was set as the default. So the big differentiator in Scalr here is the management of those provider configurations at the account scope, then assigned to the environments, and then automatically inherited by the workspaces. If I wanted to add others, I can. And here you see I have those other provider configurations that you saw at the environment scope. But really, it's that inheritance model with our organizational structure that we talked about in the beginning of this video. Okay, now moving on to policy. So in Scalr, we use Open Policy Agent for policy checks during the run. Very similar to Terraform Cloud, who also uses Open Policy Agent. We also have similar enforcement levels. So in Scalr, you can set three different types of enforcement levels, being advisory, which is really just a notification; a soft policy, which is if the policy is violated, it's going to go into an approval state. Somebody with the proper permissions can override it. And then a hard policy, which means if the policy is violated, automatically stop the run. So in terms of the main implementation of OPA, you're really not going to see much difference across any of the products out there that support Terraform. Now, the key differentiator with Scalr is at, again, the account scope. So we come up to the account scope and to go to our policy engine here. All policies are managed again at the account scope. And just like provider configurations, the policies are then enforced with all current and future environments, or you can pick and choose the environments to enforce them on. But really what the biggest differentiator here is our policy impact analysis. So if you're familiar with Terraform dry runs or speculative runs, we have that same concept, but with OPA policies. Basically, before you merge your OPA policy changes into main, you want to understand what impact that is going to have on all of your environments and workspaces that it's associated with. So with our policy impact analysis, when somebody opens up that PR, we're going to run checks and we're going to return the results that if you were to merge this right now, here's what to expect. And then we list all of the information you need to know. So which workspaces are failing? Was it because of a typo? Do you actually know that you're going to break some workspaces? And now you can give that workspace owner a heads up that the change is coming. You might be merging it in, say, 2 weeks. So really what Scalr does is bring it to the next level in terms of being able to operationalize your OPA integration with the ability to have this analysis, have all the reports in a single place, and again, taking advantage of that hierarchical structure that we have in Scalr, where we can roll all information up into the account scope. Okay, so now let's talk a little bit about integrations. So in terms of similarities to Terraform Cloud, you're going to see that Scalr and Terraform Cloud support all the major VCS providers like GitHub, GitLab, Bitbucket, and Azure DevOps. You also see that Scalr and Terraform Cloud both use InfraCost for cost estimation, but now here's where the differentiators come in. First off, if you are an Okta user, Scalr is in the Okta catalog, and we actually do support the SCIM protocol as well. So for Okta as well as Microsoft Entra, you can use the SCIM protocol, which will automatically provision teams and users and deprovision teams and users automatically for you. So you don't have to worry about the cleanup of users and things like that, as users and teams are changing. Scalr does support any other provider that uses SAML 2.0, but we just do have that direct integration with Okta. What you're also going to see is that we have integrations with Slack, Teams, and Datadog. So starting off with Slack, you'll get notifications based on run events. So you have the ability to control which run events you want notifications to be sent for, which kind of runs, which environments and workspaces those notifications be sent for. And then from Slack, you'll have the ability to see all of the details, review the run, where you're going to get the plan output as well, which can be seen here. And then you can actually go directly into the notifications and approve the run right from Slack. And that'll be sent over into Scalr, where you'll then see that run is now executing. That same functionality exists for Microsoft Teams. So we won't go over that, but very similar, it's just being sent to the Teams application. We also have an integration with Datadog. So with Datadog, we have a couple integrations actually. First off, we stream all run event details to Datadog for analysis. So were the runs successful? Were they discarded? Did they error? Were they planned and finished? By which environments? You get the execution time. So there's a lot of different information you could intake into Datadog and then use that for analysis. We also send metrics around your run queues. How are you doing with your run concurrency? How many workspaces have been created? All of those different things that you might need at scale. And then lastly, audit logs are sent into Datadog. So who created a workspace? Who deleted a workspace? Who executed a run? Where did it happen? How did it happen? All of the information is sent into Datadog for deeper analysis. So those are just a few of the integrations. It's one of the themes and strategies that Scalr is going to continue to build upon. So check out more soon for more on our integration strategy. And now we get to probably the most important differentiator, which is pricing. The only thing that Scalr charges for is a run. We have two tiers, which is free and paid. Free has the entire product, every single feature, nothing is gated up to 50 runs. Beyond 50 runs, you would need to upgrade to the paid tier. And with the paid tier, again, the only thing that factors in is a run. If you need extra agents, if you need extra users, all of that is included. We do have quotas to avoid abuse, but all of them are soft quotas. There's no extra charge, even support's included. So the only thing you need to factor into the cost is a run. And with the paid tier, you have two options, which is either monthly or annual. Either option that you select, as you increase the number of runs that you purchase, the price per run goes down, so the volume discount is built in directly. With monthly plans, you predict your month-to-month usage. You have your prepaid runs. If you go over that prepaid amount, you then have the flex run rate. The advantage of annual plans is twofold. First off, you don't have to predict month-to-month usage, so you have 1 year from the purchase date to use all of your runs. If you run out early, you just renew early and the subscription starts over. The other advantage is that you get the bulk discount on the total number of runs purchased for the year, rather than the discount on the month-to-month.